This video will cover section 5.2 on systems of linear equations in 3 variables. Just a quick note that this section is simply a review of solving 3 variable systems, and we will revisit this topic in chapter 6 using matrices. So when we get to section 6.2, we will have an alternate method using your calculator to do the exact same type of problem. But for now, we're going to walk through the algebraic steps. So there are only 3 problems assigned in the homework for this section because we will come back to it later. So I'm just going to go through one example and that's it. So a 3 variable system of linear equations would look something like this. 3 equations and we have 3 unknowns, x, y, and z. 2x plus 3y plus 7z equals 13, 3x plus 2y minus 5z equals negative 22, and 5x plus 7y minus 3z equals negative 28. All right, so here are the 4 steps that we would follow to solve these types of problems. Step 1, choose 2 of the equations and eliminate a variable. So choose any 2 equations from the 3, pick either x, y, or z to get rid of. So to do that, we'll walk through the steps, but that basically just means creating opposite coefficients for that variable and then adding together to get it to cancel out. Step 2, choose a different pair of equations, so not the same 2 that you used in step 1, but choose a different pair, but eliminate the same variable. So if you chose to eliminate x in step 1, you must eliminate x in step 2. So the result of step 1 will be an equation with 2 variables because you've eliminated one. The result of step 2 will be an equation that contains the same 2 variables. So our step 3 is to solve the 2 variable system using the results from step 1 and 2. So we take the answer we got in step 1 and the answer we got in step 2 and create a 2 variable system that we would need to solve. And then finally, step 4, once I've done step 3, I'll have the answers for 2 of my 3 variables. And then step 4, substitute those values obtained in step 3 back into one of the original equations and solve for the remaining variable. So we're going to solve this problem by doing those 4 things. So I'm going to start by taking the first 2 equations, 2x plus 3y plus 7z equals 13, and 3x plus 2y minus 5z equals negative 22, and I'm going to choose to eliminate x. So if this has a 2x and this has a coefficient 3x, I need to multiply through by whatever numbers are necessary to make the coefficients of x opposites. So if one's a 3 and one's a 2, we need to make one of them a 6 and one of them a negative 6. That's the least common multiple of 3 and 2. So if I want this to be a 6, this whole equation would get multiplied by a 3. And to make this number a negative 6, that means this whole equation would have to get multiplied by a negative 2. This is a skill that you should already have learned how to do. So we are just reviewing this topic. So we get 6x plus 9y plus 21z equals 39. And then the second equation, we get negative 6x minus 4y plus 10z equals positive 44. So notice now my coefficients of x are opposite. So when I add the equations together, the x terms will cancel. We'll have 9y minus 4y is 5y. 21z plus 10z is 31z equals 39 plus 44 is 83. So this is the result of step 1. Step 2, choose a different pair. So I chose to take the first equation and the last equation. And since I eliminated x in step 1, I have to eliminate x again. So if I want the x's to drop out, I have a 5 and a 2, so I need to make one of them a 10 and one of them a negative 10. So multiply the top by 5 will make this coefficient a 10. And then if I multiply the bottom by negative 2, it'll make this coefficient a negative 10. So distributing 5 through the top gives me 10x plus 15y plus 35z equals 65. Multiplying negative 2 through the second equation gives me negative 10x minus 14y plus 6z equals 56. Now when I add together, the x terms cancel again. 15y minus 14y is just 1y, or y, plus 35z plus 6z is plus 41z, equals 65 plus 56 is 121. So this is the result of step 2. Step 3, we take the result of step 1 and the result of step 2 and pair them together. 5y plus 31z equals 83, and y plus 41z equals 121. So we create a smaller 2-variable, 2-equation system. And we need to solve this. I'm going to stick with the elimination method. You could also solve by substitution if you would like. We will review substitution method in section 4. But if you remember how to do that from learning it before, that's certainly okay to use here. If we stick with elimination, however, I have a 5y in the first equation, and if I multiply the second equation by -5, we'll get the opposite coefficient of y, so we'll be eliminating y. So 5y plus 31z equals 83. I don't have to do anything to the first one, but I would multiply the second one by -5, giving me -5y minus 205z equals -605. When I add these together now, my y's will cancel. So 31 minus 205 will be -174z equals 83 minus 605, -522. So dividing both sides by -174 gives me the z value of 3. So I have found one of my 3 variables. So to finish solving this system in step 3, I'm going to take my answer I got for z and I'm going to plug it back into one of the originals. I chose to use this second equation to plug in my 3. So y plus 41 times 3 equals 121. 41 times 3 is 123. So if I subtract the 123, y would equal 121 minus 123, or y would equal -2. So that is the result of solving this 2-variable system for both variables. Now step 4 says, substitute the values obtained in step 3, the values I got for the 2 variables here, back into one of the originals and solve for the remaining variable. So the remaining variable that I don't know yet is x. So if I go back to my first equation, 2x plus 3 times y, I'm plugging in my -2 for y, plus 7 times z, we're plugging in 3 for z, equals 13. So that's 2x minus 6 plus 21 equals 13. -6 and 21 would simplify to 15, so 2x plus 15 equals 13. Subtracting 15 from both sides, 2x equals -2, and then dividing by 2 on both sides, x equals -1. So once you have found all 3 variables, your solution set will be the ordered triple. We would list in the parentheses x first, -1, comma, then the y value, -2, comma, and then your z value, 3. Close the parentheses. In this section, every problem has a single ordered triple answer. We will address situations where you could possibly have no solution or infinite solutions when we get to chapter 6. And that is the end of this section. Remember, there's only 3 problems in the homework. They all will work just like we did this problem, and you should get a single ordered triple, an x, a y, and a z value.